Okay, I've gone ahead and launched. And I'm going to launch the first poll question. Looks like people are starting to join us here.
Yep.
Stephanie, can you hear me?
I can hear you, and we've gone ahead and launched. We're just waiting for some participants to join the call.
Any participant.
Yeah, no, it looks like we've already got a good number of people here. And people are letting us know where they're from. So it looks like we've got coast to coast. So that's pretty cool. I'll just wait for a few more to join and to let us know where they're from. Here we go. So I'm going to go ahead and end the polling here and share those results. So it looks like the majority of people are from Ontario, with some from British Columbia, Alberta, and the Atlantic provinces. So that's fantastic. We've got coast to coast here. We've got a second poll question because we want to know what occupation everyone is in. So let us know. There's a list there of 10 different options. So scroll down if you don't see yours. It may be down below. Oh, it looks like a wide mix. Yeah, it looks like we've got representation in every single one of the categories, including other. That's what I'm always curious about. Have to figure out where what occupation. For the people in other, how about in the chat? You'll see that in the bottom there. Let us know what occupation you're in. All right, so I will share those results.
I think you'll find it's mostly my relatives, maybe.
Oh, is it? Got the what do you call that? The fan club joining in. So it looks like the majority of attendees are builders. We've got renovators. Excellent. I've been a renovator for 13 years, so that's good to see that. Some in the trades and construction, engineers, energy advisors, designers. Oh, that's good. I would like to for the designers, let me know in the chat what you design. Energy advisors, government at provincial, federal, and municipal. We've got suppliers, manufacturers, utilities, and then others. So I've already instructed a few to give us a bit more specifics. All right, so before we begin, and I just want to make sure everybody can hear us. So do me just a favor, please, and you'll see the little raise hand function. Just raise your hand just so that I can make sure that everybody can hear us, and then we'll get going. Okay, excellent. Yeah, it looks like a lot of people are raising your hands, so that's perfect. So you can go ahead and put your hands down. Okay, so what I'll do is I'll move right into the introduction. My name is Stephanie Coleman, and I work with Building Knowledge Canada. And so I want to welcome you to our first webinar in the Advanced Building Science webinar series. This is sponsored by Enbridge and is hosted by Building Knowledge. And Susan from Enbridge is going to speak a little bit more to it, but this is a monthly webinar that is running between now and the end of December next year. So you can look forward to about, almost a year and a half of webinars that are upcoming. I put in the chat, the very first chat post is a link to the list of webinars that are available. So you can find that link there, and I'll share it with you again after. Today, Gord Cooke, who's the president of Building Knowledge, will be sharing with us 5 ways high-performance homes outshine code-built homes. So before I hand the stage off to Gord, I would like to just go through a few Zoom housekeeping things. So first of all, the Q&A function that you see there, that is really ideal for any questions that you have for Gord And so if you have questions for him, please enter the questions in the Q&A. And what will happen is occasionally throughout the session, I'll interject and I'll ask the questions for you. For the chat, if what you could do there is that save that for just general comments or technical challenge, like if you run into a technical issue with the Zoom or something like that, you can put that in there. And of course, if we do run into any technical issues, I'll communicate with you by email, because you never know if we have power outages or internet things, we discover this happens. But so I'll communicate with you by email should there be any major technical difficulties. So that's all the Zoom housekeeping I have. And I would like to hand the floor over to Susan Cudahy from Enbridge, and who have generously sponsored this. So Susan, you're up.
Thanks, Stephanie. So welcome everyone. Just on behalf of Enbridge Gas, we're really pleased to see everyone participating in today's session. I don't think that there's a more relevant topic than what we'll be discussing today, which is how high performance homes outshine code-built homes during a pandemic. So I don't think ever before has there been a focus on our home environments as a place that we now not only live, but work, play. A lot of us are schooling our kids, work out, and just keep our families healthy and safe. So there's never been a greater focus on it than now. Really great content, and I know we'll come away with a lot of good new learnings, as we always do when we have Gord as our instructor. As Steph was mentioning, we're providing a whole year-long series of webinars. And so we want to invite you to next month, which is a beginning of a 4-part series with Doug Terry as he launches his new book, which is a builder's guide to net zero homes. And I know that Doug is very focused on using his own personal experiences to provide you guys as fellow builders with some of the learnings from his mistakes and some of his lessons learned. So registrations are open. Love to have you join us for those. And just sort of in closing, all of us know that the challenges that we are all facing during this pandemic can have impact on our mental health. So the numbers and the cases continue to rise, some fears of second waves, what the future might hold. It can create some unsettling questions and some confusion. So we just want to ask today that all of you take the time to reach out to each other, provide support in a tough time, make sure that none of us feel that we are left alone or left behind at a tough time. So now is not the time to let your guard down. Stay vigilant with protocols and stay kind to each other, because together we're going to get out of this and make it to the other side. So again, on behalf of Enbridge, we look forward to having you participate and to the opportunity to continue to be your energy provider of choice. And with that, I'll turn it back to you, Steph.
Thank you so much, Susan, and thank you to Enbridge for sponsoring. So I'm sure most of the people on the call are familiar with Gord. Either they have met him or you have heard of him at least. Gord is a professional engineer, trainer, author, and building science consultant, and he's the president of Building Knowledge Canada. So Gord, the floor is yours.
Oh, thanks, Steph. You're going to let me share? Yep.
Yeah, I have opened the screen there, so you should be able to share.
How's it looking?
It looks great. I can see the full screen.
So first, let me just thank Susan again. Susan's such a great friend. You and I have traveled together, been to various events. Such a great partner in the industry. I just can't speak enough. Of course, you always give me this opportunity to speak. That's so kind of you. But then that lovely message, as you just mentioned, is in this time of stress, let's try to be non-judgmental. Let's just help folks out. So thanks, Susan, for that. I really appreciate it. And as Susan said, this seems like a timely topic. Well, I got my first question in mid-March. My own brother said to me, "This is probably stuff you know about, right? This idea that somehow the air quality, that we could help manage air quality." So I've written a couple of articles on it, done some research on it, trying to stay in touch with what exactly we can do in the housing world generally, or in the building world generally, to help with. And let's be really clear, it's still about physical distancing. It's still about hand washing. It's about managing, understanding the way the virus is in how it infects, that it has to be breathed in. And so we have limited things that we can do, but we're still going to be a part of this. And I'd like to highlight that today, is to highlight just the kinds of things that you can do. What a very important theme, though, is the same things that you do to make houses energy efficient, high performance, are frankly the same things that we've known for over 40 years improves air quality, or at least the opportunity for air quality, health, comfort, wellness. So that's the most important thing. We have you for about an hour and a half, done at 2:30. I'll probably try to finish up. I always promise I'm going to finish up a little early, get time for questions. Steph does have my ear. She knows that if there's a question, a burning question, by all means put it in the Q&A, and she will interrupt and let us know. And then at the end, if you want to turn on your mics and ask a couple of questions, that would be fine as well. So let's talk about this idea of high performance and what it means in the pandemic. And it occurred to me, it's been a while since we've actually defined high performance. So I want to actually go back to a very old list, a list that was developed in the mid-'80s, to help understand what we thought high performance meant then and some of the changes that have occurred. And we'll contrast that with how code's done with that list. And we'll talk about the building science synergies of air, heat, moisture flow. We'll talk about how they simultaneously improve health, safety, comfort, durability. And then Steph said, let's do 5 values. Of course, there's more than 5, but I'm going to try to highlight 5. And some of you will know that I kind of bridge between the technical side and the sales side. One of the questions you're going to ask me, is it okay for us to talk about this? I don't want to make it sound like we're selling snake oil. I just finished a series of webinars for Fortis BC for HVAC contractors on what's okay to say to homeowners, what is legitimate and what might be seen as taking advantage of the situation. So I do want to talk to you a little bit about the sales side of this and what is appropriate for you to say on the sales and marketing side, marketing and sales side. So let's get started and think about that. I'm showing this image because this was an R2000 house. My good friend Ron Seaman, he was a builder. Now Derek and his son has taken over. They've built a couple of net zero places for myself and my family. This is a house that they actually built in 1986. This was Ron's house and then became his office. Thinking about home office spaces, you'll notice this was actually spray foamed from the outside. That was their methodology. And so these were the early days. 1982 was the start of the R2000 program. So I thought I'd give you a sense of back then. So that's almost 40 years ago, 38 years ago. What did we think was high performance back then? And there was actually a list made of the things that you should do, and more or less in the right order. That is, what order should we be thinking of these things first? So let's get started. A quick little list, 10, 11 items. If you're a note taker, take notes, or Steph, you're actually going to provide the presentation at the end, but it's useful to take notes just as a bit of a memory aid. So the first thing you need to recognize is back then we were spillage susceptible appliances, natural draft appliances. And the very first element of a high performance house is in fact combustion safety. Getting to direct vent, sealed combustion, understanding combustion processes. After all, you wouldn't want to kill anybody. This was the ultimate in indoor air quality. Can't have a high performance house if we have the chance of carbon monoxide spilling or the chance of carbon dioxide and nitrous oxide spilling into a house. So you can start to see, even in the earliest days, there was concerns and issues around indoor air quality in high performance houses or in houses in general. And what you should know is the directives came in code. So we've recognized that in the early 80s. And in 1990 in the Ontario Building Code, 95 in the National Building Code, there was specific mentions made of the possibility of combustion backdrafting, spillage of appliances. In the Ontario Building Code, we started to move towards high efficiency equipment. In the National Building Code, there was just sections in there that said if you were putting in chimneys, you got to do some work to make sure they're not going to backdraft. So the code kind of caught on to this one early on. It wasn't completely done, I would say, until a few years ago, where now high efficiency furnaces are, direct vent sealed combustion furnaces are a code requirement, or actually an efficiency requirement. So we haven't really finished until now. And you might say, well, and we still have wood burning appliances. Absolutely, we do. And not to say they're unsafe, but we do need to think about in high performance houses, what is the impact of combustion spillage plants? So that's item number one. Item number two, you may be surprised at this, but item number two on the list in 1982 was mechanical ventilation. That is, you weren't allowed to do anything else until you first managed combustion safety. Second, you managed mechanical ventilation. That too made its way into code in 1993 in the Ontario.
Gord, I think I may have lost audio. Yeah, we did just lose audio. I've gotten some confirmation from some individuals. Okay, so he's just working out the audio. And yeah, I think we've all lost a bit of audio there. So Gord's just working that out. Thank you so much for making those comments in the chat. That's perfect.
Okay, can you hear me now? The audio
Now
may
I can
not
hear
be
you.
as good.
Yep,
It may
you're
not
back.
be okay, but it's probably not as good.
Yeah, the audio's a little bit quiet, but
Not much I can do about that. I'll yell.
okay. You'll yell.
All right, let me go back to play now. Okay, so I'm not sure what you heard or didn't hear. I will just let you know that the second item on the list was mechanical ventilation. That is, number one on the list was combustion safety. Number two on the list of high performance elements was the capacity for continuous mechanical ventilation. Back in 1982, it became code in Ontario in 1990, made its way into the National Building Code, I would say more comprehensively in 95. It wasn't until 2014 that HRVs became more or less ipso facto code requirement in Ontario. Still not a specific code requirement in the National Building Code, but certainly strongly encouraged. So we'll just allow you to understand that number one was combustion, number two was mechanical ventilation. Number three on the list, through work from Harold Orr and others at the University of Saskatchewan in Ottawa, was air tightness. And as early as 1982, the R2000 program set the bar at 1.5 air change per hour, 50 pascals. That's still considered to be the go-to level for net zero. The passive house folks in Germany have said, let's go even tighter than that. Oddly enough, this is still not a code requirement, even though it was number three on the list of things to do, and still is still the most important thing that we can do. We haven't made it into code in terms of a performance metric. We have some prescriptive requirements, 17 clauses that say make a house tight, but other than Vancouver and BC now in total, that's the only place in Canada that now requires air tightness testing. Interestingly enough, United States, 28 US states now require blower door testing of all houses to an air change level of 3 in northern zones to 5 in southern zones, but at least they have that on their list. So we're still waiting for performance measures in the Canadian code, even though we've known since 82 that this is the single biggest thing that we should be doing from an overall high performance element. Number 4 on the list is higher effective R values. Imagining ourselves getting to primarily continuous insulation, doesn't have to be continuous insulation, but the idea of effective R values, that it's not just about what's in the cavity, but what's the overall performance. And the codes are moving towards that. I'm going to give you a metric. I'm going to say in all parts of Canada, as a minimum, we need an effective R value in walls of 25. Now, Edmonton, you're going to need more than that. Ottawa, maybe a little bit more than that. Certainly in Timmins, Ontario, you're going to need more than that. But generally speaking, an effective R value of 25 to 30 gets where you need to be. Codes aren't there yet. They're getting close, but they're not there. But at least codes move towards effective R value. So those are the first 4 things on our list. Next on our list is windows, high performance windows, or I would say optimizing window performance, understanding the gains versus the losses. Now we need to remind ourselves, back in the 80s, we weren't doing any air conditioning, or at least not much. And so we wanted that solar gain coming through glass. So it was all about optimizing solar gain. Our software programs were written around that. Now we've kind of done a double take and realized, wait a minute, certain parts of Canada, there's as much issue, not as much, but there is an issue in summer as well as winter. So we've thought about, let's optimize the U value, get as low as possible, and then let's optimize the solar heat gain coefficient so we get as much winter sun as we can without overheating in the summer. It started to become code directives in Ontario in 2009. That is, we started to see things like mandatory low E coatings, argon gas. National Building Code does have performance measures, as does BC Building Code in terms of glazings, but not quite as comprehensive as, say, the Net Zero program that helps us understand where to put these into the metrics. So just imagining, that's number 5 on the list. Number 6 on the list is proper water management. We started to realize in the 80s that as we add insulation to walls and attics, the drying potential of basements, walls, and attics is not there anymore, and we have to do a better job of water management. Oddly enough, this is still pretty outdated in code. Codes have actually done a really nice job below grade, other than they still require vapor barriers below grade, but they've done a nice job of encouraging drainage layers and water management. And we still have some pretty old references on the above grade portion, and I'm going to counsel builders and architects, designers on this call to make sure you're incorporating new elements with respect to water management to understand. And I'll come back to that one a second. That's number 6. Number 7 on the list. Now I've done the enclosure, let's go ahead and get to the highest possible performing mechanicals. Codes got there in terms of 96% efficient furnaces when you're installing them. We're seeing a move towards heat pump technology, of course. I shouldn't say of course, but heat pump technology. So we're going to see higher and higher performance. So codes have been working away at that one as well. And then we need to think about effective distribution. 2014, we started to see requirements for duct sealing. That's always been on our list back in the 80s to make sure that the air got where we want it to go. So that's number 8 on the list. Number 9 on the list is water heating effectiveness. And we've seen some changes there to code. Frankly, the minimum water heater effectiveness is still in the 0.67 range, but we are starting to see some increases and even interest in, certainly in condensing, but even in heat pump water heaters. So that was number 9 on the list. And I'm going to remind you, this is a list that's 40 years old. You start to check off, have I got these done? Which of these have you gotten done? And it's not a question of if you're going to be doing this, it's a question of when. Some of these are over and above code, some have already been handled by code, but I need you, the folks on this call, to start working your way through this list and make sure you have these elements. And of course, a little less in our world, maybe more in the homeowner's world, are the choices with respect to lighting, choice with respect to appliances to get that efficiency done. And then last on the list would be ready for renewables. So we imagine at some point we'll be doing renewables as a standard. Some places are already doing it. California, it's now a code requirement to put solar panels on new houses. Battery storage on the right-hand side, you can see, is becoming more interesting. So at least ready for renewables. So there's a list of 11 items. And I literally have that list from back in 1986. I've just brought it out for you. We've trained to it in the United States. The Energy Environmental Building Alliance still uses this list of these are the checklist items that you want to work yourself towards. So that's high performance, and I've highlighted some of the differences with respect to code on those 11 items, if you will. And then we remind ourselves that this actually does have really good basis in building science. That is, from day one. Well, I wouldn't say day one. In the early 70s, we built some incredibly efficient houses that were neither healthy, safe, nor durable. But by the time the R2000 program came across along in 1982, there was very much a holistic or house as a system approach. Jim White and various others coined that phrase of house as a system. And the idea that simultaneously we should be making houses healthier, safer, more durable, more comfortable, more efficient, more cost-effective, aesthetically pleasing, and ultimately sustainable. That is, we don't want to compromise one for the other. I can't put in huge panes of south-facing glass and not pretend that I'm going to have a problem in the summertime with respect to overheating and cooling issues. Similarly, we can't make a house airtight without looking after air quality. So These are the tenets that have been with us since at least 1982. You can't compromise one for the other. And you could start to imagine right here, this plays into the whole pandemic idea, that if we can make a healthier house, and I'll highlight what that means from the virus, from the COVID perspective, where we know the science is now, but we don't want to compromise on that. And interestingly enough, there are some pretty simple rules around building science. So at the same time that we would had developed the checklist, the high performance checklist, along with it came the science. The science says heat moves from hot to cold, moisture moves from hot to cold, moisture moves from more to less. These basic building science rules, these are available too, obviously, on this when you get this PDF. But go ahead and research these. Construction Instruction in the U.S., EBA, Environmental Building Alliance, they just did a series of sessions, all true to these elements. The one at the end, interesting, all the action happens at surfaces, understanding moisture and moisture dynamics in houses. These are the kinds of things that we need to get to. What I'm really saying to is those performance attributes are rooted in the science, and the science, we've kind of done the science. Nobody's arguing over the science anymore. We might be arguing over the order of those high performance elements and what's most cost effective. But everybody understands, from Steve and Straub, Thule, and all those folks, we all agree on the physics or the science of how houses work. So just important to keep that in mind as we move through this. And so I said 5 values. Let's start with the 5 values. Let's start with managing indoor moisture levels. And Steph, there is a poll question that we would like to ask. The poll question around what is the optimum or the right relative humidity range? Could you launch that poll for us? Do I have to stop sharing? No? Okay. What is the right relative humidity range? Where are those last stragglers? Thank you for that. And that's interesting. It turns out you're all winners. I was kind of trying to do the grade 2 thing. You're all winners. Frankly, we're going to see here exactly what this means, and we're going to fine-tune this a little bit. But I am glad to see you have 35 to 40 and 45 to 50 as being interesting range. The sharp ones on the call should have been asking, and probably in the chat are asking, what season are you speaking of, Gord? But thank you for doing that. Let me just, how do I get rid of that, Steph? I got to get rid of that.
You should just be able to, yeah, there's a little X. You should just be able to close the box. Yeah.
I think I got that. Yeah, but now my screen won't work. There we go. So from a moisture perspective, what we need to remind ourselves is moisture is both good and bad. Good for comfort, good for health, good for finishings and furnishings, but bad from a condensation potential, bad from a mold potential, sometimes from a health potential. We just don't want it too dry. We don't want too much moisture, on the other hand. So we do need to remind ourselves that finding a moisture balance is where we'd like to get to. Sometimes furnishings and finishings are going to absorb moisture, and that's going to be a problem as well. But typically we like to say it this way. Moisture is good for the people, but bad for the building in general is where we'd like to go to. This, though, is the important slide. I was kind of interested because we used to use this slide back in the 80s with CMHC. It's called the Sterling chart, developed back in the late 70s, early 80s. It was just validated by ASHRAE, the American Society of Heating, Refrigeration, Heating, Refrigeration, Engineers, Association of Heating, Refrigeration Engineers. You get the idea. ASHRAE, my apologies, I slipped up there. But look at this. It's kind of interesting from a virus perspective. That optimal zone is 40 to 60, and most of you were bridging on that one, so that's good news. The infectivity rate of viruses, the amount of time that it's still viable, is reduced if you can keep the relative humidity between 40 and 60%. Lower than that, and it tends to have higher infectivity rates. Higher than that, it tends to have lower infectivity rates. So this is no surprise to us. We just haven't used it in the last 40 years to talk about viruses. We used it to talk about, I don't know, ozone production. We used it to talk about mold, and you'll notice mold and fungi under 60%, you basically get rid of mold. That was my history. Keep it under 60 and you're really good shape. So this is an important slide, one we can bring back out. What this means is we've always known that 40 to 60 was in a good range. We just weren't thinking viruses. Isn't it nice to know that the same things that we've been doing in high performance houses to manage moisture for other reasons, now we find out has a really nice benefit from a COVID perspective. Now, this still doesn't, you keep it at 40 to 60 and you sneeze and immediately those viruses, nuclei die. No, that's not the case, but it reduces the length of time they're viable. So it's powerful to do. And you can imagine both new and existing housing, new and existing buildings in general. I've had a call from a large property management firm in Toronto that said, give me a few things that we should be doing. And I said, well, have your mechanical contractor check your dehumidification system in summer and your humidification system in winter to assure your tenants that they're able to maintain that 40 to 60%. Now, you and I are both knowing that in a typical old house, if we tried to keep 40% relative humidity as high as that all winter long, we would have nothing but calls and condensation. So we need to fine tune this a little bit from a Canadian context. We need to think about a winter range and a summer range. We need to think about 50% in the summer, plus or minus 5. Could we get lower than that? Yes, but it's really expensive from a dehumidification and air conditioning capacity. Winter, 35 plus or minus 5. And you go, Gord, I thought you said 40. The problem is most houses, old houses, I can't do more than 35 on cold winter days. And it's not an all or nothing. You'd want it to be at 40% most of the time. And then if you do get condensation on windows, that trumps the virus. So, because I don't want mold and damage to the windows, so I'd have to lower it. Unless you can imagine I had some features in my houses that would allow me to raise that moisture level in the wintertime. And you probably know where I'm going with this, but really important that you understand the value, the choices you're going to make. Is you look at the 11 points that you want to get to, the 11 elements of high performance houses, which of those would help you manage moisture is what you want to think about. So managing that condensation, because we don't want that condensation on surfaces, that causes, or in interstitial cavities, that of course causes problems. The bottom right picture, warm moist air leaking into a cold cavity. The bottom left picture, moisture in the foundation wall that's condensing inside the insulation blanket. And of course the ubiquitous condensation on windows, on old windows. And it turns out there's 3 opportunities to improve or reduce the risk of condensation on surfaces or in cavities. One, of course, is to warm up the surfaces, keep surfaces warmer. That is, more efficient surfaces or warmer surfaces, higher energy efficiency on those surfaces. 2, reducing or managing the relative humidity in the wintertime. And 3, managing airflow so I don't have warm, moist air leaking into cold cavities. So these are important elements. And I just need to remind you, look at these studies. As they finished the R2000 program, 1982, CMHC immediately started a bunch of research on indoor air quality. Research in 1988 on 18,000 children in 20 different communities. A study in Wallaceburg, Ontario, where they looked deeper into houses. A CMHC basement study, a pilot study on asthma that's ongoing, and still to this day an ongoing study of immune systems and housing. They are following 6,000 children. They're about 10 years into it, 7 to 10 years into it, following them and documenting what's happening in their houses and how it impacts their health and immune systems. So very powerful work that's done by CMHC and Health Canada. Out of those studies, we learned some interesting stuff. And I just want to highlight the middle too. They learned in 1988 that more mold is found in older houses than new houses. And more importantly, leakier houses have more mold than tight houses. This was the statement from CMHC. The indoor air quality in leaky houses is worse than the indoor air quality in tighter homes. We got this wrong, you and I. We talked about, we make them too tight. No, the research was done in 88 that says, no, tight is actually good. Tight is helpful. Don't take away from the fact that if you build a tight enclosure, that gives you much better opportunity for air quality control. So now you should be saying, wow, they've had this right for a long time. We need houses, in fact, to be tighter, not looser. So this is hopefully of interest to you as we move through this. Here's the basement study. No surprise here, right? That top statement. They tested 405 basements and found that more than half of them had mold problems or moisture problems in half of those houses. Then they took 27 houses that were noticeably moist and found that 15 out of 16 visibly moldy houses, toxic mold was found in 15 out of 16 of visibly moldy houses, and out of the 27 investigated. So they took some that didn't have mold, moisture problems, some that did, and always found toxic mold. And I'm shortcutting a long conversation. I will encourage you to go look up CMHC's data on this. The point is there's a link between moisture, molds, and health in houses, and we're going to link that to the pandemic and viruses as well. So very powerful research that was done. And you can start to imagine, and if you're managing moisture, trying to control moisture, it's about keeping surfaces dry through drainage and keeping materials dry during construction. It's about water managed foundations. It's about reviewing plumbing and HVAC specifications to avoid leaks. And if surfaces do get wet, let dry quickly, which means venting and ventilation, which means dehumidification. And these are the elements that you would go, am I including those in my high performance houses? And the answer would be yes. Almost by default, you are doing these things already. Contrast, I said to code's been working away at this, but think about older houses built before the 90s when those changes were made. These are houses that have severe susceptibility to moisture problems and the lack of moisture control. We end up having to add moisture in the winter, dehumidifying in the summer, and really not having the building materials available to us or within the building that are not susceptible to mold and moisture problems inside of houses. So, and one of the ones I just want to key in on, going a little deeper on this first one, I want to key in on foundations. Why foundations? Because it's really hard to live in holes in the ground. Boy, there's whole communities, cave communities, that were abandoned in the 50s because they realized this isn't good for people's health. That was Matera in Italy, 50,000 people living in a cave city, and realized that tuberculosis rates and viral bacterial rates were through the roof, and so they moved people out of those houses because living in holes in the ground isn't easy. It's so challenging. So we need to remind ourselves, there's the basement of the, well, I will say the non-high performance house, the old house. Can you smell that basement right now? And you all can smell it. It's dark, damp, musty, cold. And so we need to imagine what we can do in high performance houses to turn that into bright, dry, clean living spaces where we'd like to get to. Those new expectations for our clients who are spending more time at home. Maybe the classroom's in the basement, the office may be upstairs, or maybe it's the opposite of that. Maybe your office is downstairs and the kids upstairs. You'd like both of those places to be equally healthy. So we need those lower living areas to be warm, both from a air and foot comfort, make it dry, make it bright, make it healthy, and ultimately make it usable. So the benefit of imagining a high performance house, that you now have more usable spaces because people are using their houses differently. So that's not exactly moisture, but you see the added benefit of that. And so thinking about all the moisture sources in basements and the solutions that we have in high performance houses, recognizing that when you guys build a high performance house, because you're going to be insulating it better, you take a much better tact in terms of managing moisture in those basements. So I'm keying on moisture a little bit just in basements, just so you have a sense of how deeply we can go into this. But something as simple as a drainage layer on the outside of a basement wall on the right-hand side there. That drainage layer on the outside of that house allows you to maintain better levels of moisture, relative humidity inside the basement, because there's so many moisture sources trying to dry to the inside. And if we don't have that ability to dry to the inside, then we have to make sure we keep the water out. So very powerful, very important to understand. As simple as that is a high performance element that actually has play against the pandemic, against the virus. It means that you can manage moisture levels in basements to a much finer degree, and therefore reduce the infectivity rate of those viral components. You would have a sense of this. This is from the state of Minnesota. Minnesota now requires insulation on the outside of basement walls. You cannot insulate on the inside unless you first insulate on the outside. That's, of course, one of the elements of high performance houses that we're trying to move you guys towards. So keep that in mind. That means that concrete surface is warmer and drier, and therefore better able to manage moisture and temperatures and comfort inside of those basements. So just really powerful. Here's another choice. This was drawn by John Straub and Joe Stebrick. Another, I'll just show the animation. Some of you guys have seen this, but here's a great way to do a basement wall, high performance basement wall. 1 inch of extruded foam tight to the wall. XPS, could be EPS as well, but I'm showing XPS in this case. This is showing a spray foam brim. Doesn't have to be spray foam, but you get a sense of the kind of things that are going on to turn this into truly livable space. So a high performance house built to these kinds of specifications manages moisture, manages temperatures much better than the old house. I get this all the time. People are looking at buying an existing house. Well, the basement's finished. Is that a good thing or a bad thing? Unfortunately, we just don't have reliance that the basement is finished correctly or that it was able to manage moisture. This is just showing a blown-in insulation. It could be bat. You could foam the whole thing. That'd be fine too, but I'm just showing it as a blown-in bat system in this case. But the magic of this wall is the way it manages moisture and condensation potentials inside this element. Notice no vapor barrier on this wall. You can show by code with the right amount of foam on the outside wall that you do not need to put a vapor barrier, which would allow this wall to dry to the inside as well as to the outside, or at least maintain the moisture on the outside. The key to this wall is the understanding that moisture coming through the concrete stops at that XPS layer, stays in the concrete, not affecting the inside occupants. Moisture coming from the inside in the wintertime, rather than hitting cold concrete and condensing, it's now hitting the warmer foam. We can maintain much finer levels and tighter control over relative humidity rates in houses. And so the sum total of this, of value number one, is these are all elements of high performance houses, except maybe the one on the right hand side. When you think about high performance houses, you're using triple glazed windows, or at least you will be if you're getting towards high performance. What does that mean? That means warmer window surfaces, which means you can raise the relative humidity. Now you can manage 40, maybe even 45%, maybe not in Edmonton, but 40, 45% throughout the winter. You can maintain the level of moisture, making sure that you're airtight so that you don't have warm, moist air moving into wall cavities. You cannot raise the relative humidity in houses to 40, 45 without making sure those assemblies are airtight. Otherwise, you will have condensation in surfaces. The basement, the drainage layers, the insulation under the slab that keeps the slab warm and dry. The ERV in the bottom left, the fact that you're able to better manage through ERV technology, HRV and ERV technology, manage moisture both summer and winter, rejecting moisture in the summer and hot, humid areas, allowing moisture to be brought back in the wintertime so I don't overdry. Heat pump technologies, which in general have better capabilities with respect to moisture removal. The one on the far right is a dehumidifier. I didn't have it on the list of 11 items, but it's an item that we have added in high performance elements. That is a finer degree of moisture control. So I would want you to add the idea of moisture management, indoor moisture management, humidity management in the summertime in climate zones like southern Ontario, coastal areas of BC. In the Maritimes, you don't do much air conditioning in the Maritimes, but you should be doing dehumidification in the Maritimes. So that's one element that's not perhaps on your high performance list. I'd like you to add it to your high performance list. So that's value number one, is managing moisture. What was the number? 40 to 60. More importantly, in a Canadian context, 40 in the winter, 50, 55 in the summer is kind of where you want to get to. All of these elements of high performance houses you can now point to and say, my triple glazed windows, I put them in there partly for energy savings. More importantly, I put it in there to reduce the infectivity rate of the COVID. Isn't that an interesting topic, to be able to say your windows are a health device? The Delta wrap, in this case it's Delta, the Delta wrap on the basement is in fact a health device. Air tightness you do for health reasons. That's what I really want to get to as we move through the rest of this presentation. Second, of course, is value number two, not of course, but I should say to you, is the control of spaces. the ability now to control your own environment. Really powerful to understand the value of compartmentalization. Why do I mention this now? Because 60 to 70% of what Canada is now building is multifamily. You're no longer just out in yourself on the plains. You're typically attached to other folks. And the idea that you could compartmentalize from what's happening next door. There's a certain security, a certain safety, a certain assurance, peace of mind that people have when they know, so that they're not connected to the air next door. I'm reminded of a client, an old duplex built in the 1920s or so, an old brick building, downtown Toronto, Spadina area, and lovely old townhomes, if you will, side by side. In one is a 75-year-old man who's on oxygen, but he's a smoker, has been. He used to smoke 3 packs a day. He's happy to say he's down to a pack and a half. He's pretty much housebound. The next door is I would say, well, definitely a new up-and-coming couple with their 2 young kids who happen to be very sensitive to cigarette smoke. The challenge they gave me was, how do I separate the smoker, heavy smoker, from the non-smokers? And you might say, well, move the 75-year-old outside. Tell him he has to smoke outside. That's not tenable, right? It's not possible at this point. That would be not well, I would say unethical to say you have to move out. After all, it's his home. He owns it. What do we do with the folks next door? And the idea was to isolate the two. So what do I have to do to isolate? Well, I'd like to put the smoker under negative pressure. I'd like to put the other family under positive pressure. The problem with that equation is the houses were so leaky, not only the outside, but the inside, that, and we did it with smoke. We used a smoke bomb. We should have phoned the fire department before we did it, because smoke was everywhere, but we used the theatrical smoke, and that smoke was coming right through the double brick wall. It was impossible to seal at this point. We couldn't isolate the two. I did the calculations. In order to maintain even a modicum of pressure, we would have needed 1,000 CFM exhaust fan in the smoker suite, or 1,000 CFM of fresh air coming into the other family suite to create even a small pressure across that. If we're able to make our buildings airtight, the amount of air I need to create pressures is very, very small. They figured this out in high-rise buildings in Toronto. The Tridells and Mintos of the world have done a really nice job of understanding that the more I can isolate or encapsulate or compartmentalize suites, the less air I need in my hallways, the less makeup air I need in order to create pressures to move the air in the proper direction. But even in single-family houses, detached product, thinking about the air quality between the house and the garage, I'd like that to be tight. Between the house and the attic, between the house and a crawl space, I'd like that to be airtight. And then in multifamily, between suites and common areas, always making sure that we're able to maintain. So I just did this little presentation, as I said to you, for the HVAC industry. If you have a high risk person in your house, you'd really like to maintain a positive pressure in their room. If you had infected folks, well, you'd want a negative pressure. Now, in housing, you're probably infected people are only going to be infected for a few weeks, so you probably don't spend much time at that. But we've spent a long time, Tex McLeod and I, helping clients who are asthmatics, clients with environmental sensitivities, and now clients that might be sensitive to viruses. We would say, let's maintain a positive pressure in their room. Let's go a little further. Let's create an independent HVAC system for each of those spaces. And my point here is, in high performance houses, it's much easier to do this because if you have tight control over the building enclosure and tight control over the way that assembly is built. So the idea here is to create, it's a great term, an oasis. Imagine all of your clients who might be worried about COVID, but maybe more important, thinking about Nona, who's now come to live with them, or a young child who's just come into the house. And should we be able to create a really nice safe haven, an oasis for them? And imagining ourselves maybe with a separate heating cooling system, wouldn't have to be, but in a high performance house, how much heating cooling do you actually need for that little room? You don't need much, not like the old days where I needed 2 6-inch ducts running there. Maybe I could do this with one small little heating system or cooling system in that one area. Or better yet, let's take the HRV or ERV and dump it through a HEPA filter and positively pressurize the house. Yes, we're going to take air to other locations, but imagine taking your HRV or ERV and ducting it directly in from outside into somebody's bedroom, positively pressurizing their sleeping area with fresh filtered air. This is really nice, and you have all of the elements of this, right? You're already doing the filtrate, sorry, the ventilation system. It'd just be a matter of reducting it to create that really nice safe space for high-risk folks in that bedroom. And thinking about HEPA filtration and keeping that positive pressure in that room is very powerful. This happens to be a ERV or HRV that has a HEPA filter built into it. There's 2 or 3 on the market now. So now the fresh air comes in, gets heated, preheated, pre-cooled, manages the moisture, and now passes through a HEPA filter. Now you could duct it directly to bedrooms. See what the advantages of high performance houses might be for managing COVID. Very, very powerful. So that's number 2. We're doing really well on time. We have 3 more to do. The first was managing moisture. The second was the ability to control spaces. Third, no surprise, you might have thought it was top of mind, but I'm saying it's number 3 on the list, is the comfort of spaces. Imagining that when we understand, and you may recall at our spring camp, some of you were there, we had Robert Bean, I would say the foremost authority in Canada on comfort, and he challenged everybody to have a copy of ASHRAE 55. This is the comprehensive standard on human comfort. And what it says to you is our sense of comfort is a function of air temperature, humidity, air speed and drafts, surrounding surface temperatures, gender, age, and activities, and ultimately metabolic rate and clothing. And here's what's important. Have things changed a little bit? That is, if you're now at home, you're teaching from home, you're working from home, then you're living, you're now in that space much longer, in that particular space. And it turns out your body becomes acclimatized or sensitized to that space. And so things that didn't used to bother you because you're only there for maybe an hour or 2 in the evening in the family room, well, now it's the classroom. And now you tend to notice, yeah, it's a little chilly in here. Didn't notice it before. Maybe you wrapped yourself in a onesie, didn't worry about it. The basement's cold and clammy. Didn't used to notice because you were just maybe doing hobbies down there. Well, now it's the classroom or it's the office. So you get this heightened awareness of comfort. So it's really powerful to understand that you get to talk in high performance, the consistency in temperatures between different spaces because of the high performance elements that you've included in your houses. And in terms of that comfort challenge, understanding, reminding yourself that Robert Bean told us that about 15% of our sense of comfort is related to moisture. 35% is related to the air temperature around us, the conduction and convection of the air, but fully 50% is associated with the surrounding surface temperatures. And we have been, of course, increasing the number of windows in houses over the last 15 or 20 years. We've basically doubled the window-to-wall percentages, which is a great thing. And again, maybe that wasn't a big issue, but that big pane of east-facing glass used to go off to work at 8 in the morning. Somebody went off to work, didn't notice that that room was overheating because by the time they came back in the evening, now the sun's around the west. That east-facing room is now your home office or the school classroom. Oops, that overheating becomes an issue for you early in the morning hours. And then in the afternoon, it's the west-facing windows that are a problem. So understanding these changes, and I would just highlight this idea. There's the ubiquitous home office, right? Doesn't this look idyllic? But does this change the time spent indoors and the fact that it's day and night and the changes we're going to see? High performance houses. I can tell you, my nieces and nephews, some of you will know if you go to buildingknowledge.ca, there's a series of cottage videos. My brothers and I built a cottage. It's been continuously occupied now from mid of March through to just the last weekend, Thanksgiving weekend. Why? Because my nieces and nephews are realizing rather than working from their 500 square foot condo in Toronto where the sun beats in and then it's cool at night, they're coming to the net zero high performance house because it's more comfortable, more natural light without the interruptions, if you will, or the problems that they might have with comfort, the moisture management and so on. And the types of activities have changed. Susan highlighted, maybe it's a school classroom, kids running around. Maybe it's home office, and what are your office activities? Maybe you're actually expected to do some drawing or some work. I don't really know what those activities might be. Maybe you're managing or creating moisture, or maybe there's a need for there to be a management of moisture for your work items, for the papers that you're working on, and so on. So, and even requirements for sound control need to be, and from head to toe, the temperature, humidity, and light. Of course, we're going to want that natural light, but that light comes with a penalty, at least in an old house or code build house, with overheating from that glass or overcooling, radiant losses at night. So you can start to imagine the window choices that you're going to make. The triple glaze, the proper coatings are going to help with proper light, proper humidity control, proper sound control, because sound is just another transfer of energy, right? We stop heat flow, energy in the form of heat. Now we're going to stop energy in the form of sound transmission. So the choices you make in high performance houses have not only an energy benefit, they now have with this change in expectations that we get from our clients. So the control of comfort, the ability, and remind yourself that this is it's your body become acclimatized. Things that didn't used to bother you in your home now will bother you. And there's going to be interest, more interest. Your salespeople can talk more about the comfort levels. What exactly are you doing from home? Is this the classroom? Is this the office? Or is it still just a domicile for sleeping? So that's we need to remind ourselves as to where things are happening. And notice the same things on the list. The same elements that help from a moisture perspective also help from a comfort perspective. The basement's a warmer, more inviting space. The windows, we can have more natural light. The air tightness, we don't have the draft and the noise coming through those elements. The ERV, keeping that moisture balance, summer and winter, and good quality quantity of fresh air. And you may say, do I need more fresh air? And the answer is, of course you do. You need more fresh air. Let's talk about that just briefly. Your kids were at school. Most, if any new school built after 1990 has had an assurance of 15 cubic feet per minute per person of air. 15 cubic feet per person per student, if you will. And now those kids are at home. We'd want to make sure our ventilation system. Some people, I turn that off during the day. I don't need it. Right, turn it back on, because you want your house, now that it's the classroom, to be ventilated at least as well as their school was, and in fact, maybe more. So maybe we need to think about larger HRVs or ERVs, or making sure they're balanced, and help people understand that the operation of those pieces of equipment may need to change if you're spending more time at home. So the same things that we did for moisture also help us from a comfort perspective. Number 4, I'd be remiss, and you might say, it's a bit of a stretch. No, it's not. Sorry, staff, question?
Yeah, a couple of questions came in, so I thought I'd take this time before you move on to 4 to touch on those. So the first one is, it's a question on market trends. So because basements are expensive to build and challenging from a moisture perspective, they increased risk of flooding due to climate change and daylighting challenges. Do you see any market trend moving away from basements in Canada?
That actually may have been my brother asking that, because that's what he asked me. Why aren't we doing a basement in this cottage that we were building? I said, we're not building basements because we're near the lake, chance of flooding. Here's what we're going to do, Jim. We're going to build up. We're going to take an attic truss, and we're going to put some space up above. So much like they do in the South, right? They build slab on grade, some of them even building on stilts now. And then they'll use an attic truss and actually build some space there. So my opinion would be that basements we could avoid. And when we've developed really nice, comfortable spaces up above, we go, okay, let's find a new place for storage or a new opportunity. That said, if we're doing high performance houses and doing a better job of basements, some might say ICF by all means, but it might not necessarily have to be ICF, but really proper location of foam. Foam's on the outside, a really good water management system on the inside, really good slab. Those basements are no longer at risk. Still at risk from flooding, perhaps, but at least from a moisture management on a day-to-day basis. So by all means, go ahead and get rid of basements, but we can also do a better job of basements if we find them to be a better place. I will say this, builders, start offering finished basements more and more. I know you hate doing it because it's out of sync and you end up with a warranty, but let's be clear. they're going to finish the basement anyway, and now it's going to be the boys with the pizza and the beer finishing on the weekend, and you're still going to be liable for it. So go ahead, build a high-performance basement, start insulating to the outside under the slab, so you can predict that your clients are going to be healthy and comfortable down there. Was there another question, Seth?
And you should gift them with a dehumidifier.
Gift them with a dehumidifier. Whole house dehumidifier, absolutely. Next,
yeah, that's right.
Another question?
The same person asked another question, and he was asking about the attic. You talked about lifting, adjusting the attic. So could you just repeat what you said on the attic?
I was just saying that rather than, we tend to build higher and higher pitch. Everybody loves that 8, 12, 12, 12 pitch, which ends up being a lot of space up there. That if we realign the trusses and went to an attic truss or attic space, we now would have a bonus room. Excuse me. The one little house we built, that's exactly what we did, just with an attic truss. And now we have an extra 600 square feet of bonus space for storage for the kids' classroom, whatever that happens to be. So there are techniques to take that attic and turn it into usable space.
Yeah, that's where you take the bottom cord and it's basically floor joist tied in, right? Yeah.
That's right, exactly.
Yeah. So the second question is, what is the sill plate used in the basement insulation? Is it raised off the floor?
The sill plate, I'm not sure what that was about.
I'm wondering, perhaps...
bottom plate off the wall, perhaps, is that right?
What is the sill plate used in the basement insulation? Is it raised off the floor? I'm not sure. Perhaps that person can clarify the question, but I know sometimes, like say if in retrofit, I think if they put insulation in or have to lift, they put in a couple of sill plates to lift so you don't lose some ceiling height, but I'm not sure if that's what that's referencing.
Was there somebody there who had that question? They could elaborate.
Thomas, did you want to speak? I could put your mic on, or you could ask the question again in the questions. Not seeing anything. So maybe we can continue and then
we'll continue. We'll come back. Sure.
Yeah.
Thank you. All right. So let's go to value number 4. Number 1 was moisture management. Number 2 was control of spaces. Number 3 was improved comfort. Number 4 is durability and resiliency. And you're going to, what's that got to do with the COVID? Again, because this is a new type of investment, right? People are going to start to think about their house and the kinds of work that needs to get done. And if they're taking an existing house or even a code build house and saying, yeah, now it's going to be my home office, we're going to be able to say to them, actually, it's really tough to make a basement, existing basement, or even a new code built house without proper moisture management in basements, without proper insulation under the slab, really difficult, frankly, to turn that into truly livable or usable space. More importantly, I just want to make the connection to building science that I've said we've known since 1982, the same things that make houses more energy efficient also make them healthier, safer, more comfortable, but most importantly, more durable. That is not most importantly, but importantly, more durable. Durable from the sense of I have less work to do. I don't have to spend money, invest money on simply upkeeping the house. If I truly understand heat, air, and moisture flow, remind yourself that moisture is the #1 thing that destroys buildings and building materials. We're going to do a better job of moisture management inside the building. We need to think about a better job of moisture management on the outside of that building. And when we imagine the moisture sources in houses, and when we imagine the risk that's changed, that is, we used to rely on roof and roof overhangs to do our deflection of our moisture. Big overhangs. Now we're building more modern, flat roof, more bump out windows, and now we're relying on the windows and the cladding system to deflect water away. So of course we want that deflection, but we need to understand the risks have gone up in our houses. Steph?
Yes, okay, so Thomas has provided clarity. So he said in your schematic, it showed a frame wall inside the continuous insulation. The bottom 2x4 was a different color and appeared raised off the floor and was pinned down.
Great, I love that. I'll answer that after I finish this animation. Is that okay?
Yep.
Yep, thank you. I'll do that for you. So we were talking about deflection and of moisture and understanding that our risk factors have gone up. And remember, We have more insulation on our walls and attics, therefore less drying potential. So we do need to be mindful and thinking about extreme storms, those kinds of issues. So we used to rely on cladding and cladding materials and our roof overhangs to give us that deflection. Now we need to recognize, we always needed to recognize, that water actually does get in behind that cladding system. And when it gets in behind, we need to let it out. So we need to do a more comprehensive job, and high performance builders tend to be doing that. When you put continuous insulation on the outside and then strap out from there, you're creating really nice drainage planes. So when you're using continuous insulation, you also get to talk about the durability benefits. The next item on the list, of course, would be, and there's our good grading and drainage as well. The next item on the list would be the drying potential, and mindful of the fact that we have less drying potential in our buildings, and high performance houses recognize that with the type of sheathing products, the choices we make with respect to weather barriers, the choices we make on the inside of basements, for example, with respect to drying capacity of vapor barriers to allow moisture to drive back into the building and the basement. These all become really nice building science mantras or metrics with respect to durability. So the same things that you do, insulated sheathing example, air tightness as an example, those same things help us with the durability and the resiliency side of that. This idea of managing deflection, managing drainage, managing drying, understanding the elements of building science. All high performance builders have taken specific building science training to help them understand those key elements. And I just wanted to show you a quick example of, counting the risk factors. This is the new normal, right? The 4 different cladding systems, the pitched roof falling into a parapet, some flat roof elements, some conditioned space that's underneath unconditioned space. The risk factors have gone up. The bump out windows, the no overhangs. We need to be mindful when you build high performance houses. We are doing a better job of these kinds of elements. And we have these added risk factors, the more wetting potential, the more sensitive materials, and different water management principles of those different cladding systems. On the bottom left, they're actually watering this building. Within 20 minutes, this water ends up in the unit downstairs, 12 feet back, inside the kitchen ceiling. So we need to, this is by no means a high performance builder in this location or in this application. So the same things that you do for safe, healthy, comfortable, energy efficient also have an impact on durability. So making sure that we're managing water correctly in the way we install our windows. So we try to find those appropriate materials. And I would say the regular code build houses are still using red tape as flashing, and high performance builders on this call would say no, that does not meet requirements. Even though the code may say it's okay and the local building official said it's okay, this is not high performance. Red tape is not a flashing. We need to recognize the difference between air barriers and weather barriers, and in high performance training, that's what you're getting. So these penetrations not properly sealed, mechanical penetrations. So we have to help ourselves understand that we're building high performance houses that are good against air, good against heat, but most importantly, good against moisture is where we want to get to. I always like to show this quick animation of the 10 points. Remember I said 11 points for high performance? Here's the 10 points of proper window install. First, we should be sloping sills. Not all of you do. If you're not going to slope, you should at least be putting a back dam on the inside, not with foam, but with caulking. 2, a properly installed weather resistant barrier with proper button cap fasteners, not staples anymore, button cap fasteners. 3, the proper cut. I still see this done wrong all across the country. Proper cut that leaves the head and the sill clean and allows the jambs to be protected. That's point number 3. Point number 4 is that weather barrier up so that the window flange can go underneath. Point number 5 would be fully protected sill. Fully protected sill to make sure that when water does leak in, it's not damaging that sill. That's point number 5. Point number 6 is if a pressure roller shows up on site. All tapes have to be pressure rolled. Point number 7 is caulked on 3 sides, not the bottom, to let moisture out. Point number 8 is the window going in with the proper fasteners. Then 9 is the proper sequencing of flashing, and number 10 is folding that weather barrier back down to keep that shingled lapped effect. I see so many code houses that are not done correctly. I see most high performance builders doing windows correctly. If there's 10 points, how many are you getting? More importantly, how many do your clients think you should be getting? If you're back at school, What's a good number? 5 out of 6, sorry, 5 out of 10, 7 out of 10? I'm going to say to builders on this call, I need to be 7 to 8 out of 10 of those elements. Maybe you don't slope the sill. I'm okay with that. But let's make sure we're flashing our windows correctly so that we score 10 out of 10 or at least 8 out of 10 on our window installs. And then I just wanted to highlight again the idea of proper moisture management. If warm, moist air from the house at even 30% relative humidity happens to get into a wall cavity, hits that OSB in the code A1 in Ontario, in the minimum code requirements of in a house in the National Building Code, we're going to have condensation. And there's 2 ways to get rid of that condensation potential. 1, stop the air leaks, or 2, put insulated sheathing on the outside. And it turns out when you put R10 on the outside, in virtually every climate zone in Canada, you have no chance of condensation in the wall. When you put in when you make a wall airtight and when you put insulated sheeting on the outside, you effectively have no chance of interstitial condensation. See where we're going with this? The durability. The same things you did for high performance. That continuous insulation, one of its single biggest attributes is it stopped the potential for moisture inside of walls. And why is that more important than ever? Because homeowners are going to want to keep the relative humidity not at 25, not at 30 like they used to, but 40 to 45. Why? Because of COVID, and they've been told to manage moisture inside their buildings. The synergies of the building science. I won't do this one. You guys have seen that. Number 5 on the list is the cost of ownership. And I get to come to this one every time. The money's always at the end, but let's make sure we understand that it's a new investment. It's a new conversation with our homeowners, that they are now not just investing in a home that they're going to sleep in hours a day. They're now investing in their office building, in their school, in their play areas. This is a new investment, and they're going to want to hear the fact that you have energy model, that you have helped them based on a software. There's other software, but based on a energy simulation software with a registered energy advisor, that you are partnering with your trades and suppliers to find, through an integrated design process, the optimized performance of that building. So it's not just, well, code says, code says, code says. No, this is specific to your area, specific to your style of buildings that you're building, the type of building, the usage of that building. So getting that best value by going through this process, if you will, is so powerful in this conversation. And what it means is when you optimize and we move through from, say, a code build house on the left through to a net zero ready home, and you look at that investment down at the bottom, if you can read quickly, to take a code build house and make it net zero, you'd need 102 solar panels. But on the right hand side, you'd need 49 solar panels. This is the kind of investment decision that you can help your clients with. And you can say, really, we're going to link COVID to solar? And the answer is yes. This is now a building where they conceivably could be their life for 24 hours a day for the next, I don't know, 5-10 years. They're going to work from home from now on. Who knows, right? A lot of people, I know my son and future daughter-in-law, they're saying they're making a move to outside the city because they now feel they can work from home for the rest of the foreseeable future if they will. So they're looking to upgrade, find a house that they can make sure meets their investment needs. So they're thinking down the road of, where do I want this house to get to? And this idea that of all the high performance elements that you're building in your houses actually works really well against the idea of how many solar panels. So optimizing the enclosure against the future cost of renewables, that I think is a very powerful term that you want to think about. I do it in straight money terms as well. Some of you have seen me do this before, but here's the conversation. How much does net zero ready cost? Well, in most areas of the country, it's about 15 grand. And people always say to me, is it worth it? Well, okay, you're a homeowner. Is it worth it? I always ask, have you got $15,000? Yeah. Where is it? Well, it's in the bank. What's it earning? 2 to 3%. Good for you. That's a pretty good investment. That $15,000 on the left-hand side is earning you about $300 to $450 a year. What if you kept that money, put it into your house, and invested it in the house? And you'll find, through the graces of Enbridge and allowing you to encourage you, quite frankly, to use energy more wisely, you're going to say, I'm going to use a little less gas in the order of $85 a month. And if I said I'm going to borrow the $15,000 on the right-hand side, the extra cost of that loan is only in the order of $75 a month. And so I pay the bank $75 a month more. I pay the utility, Enbridge in this case, $85 less. And Susan's saying, yep, that's fine. We're good with that. And now you've got a better home for basically the same price. Now, not only a better home, but a better school and a better office. In other words, my point out of this savings, you now get to double down or triple down on this when you start thinking about a COVID reality. That is, people are going to recognize this is a different investment equation. When they're spending more time from home, it means that they are ready to invest more. And they understand this. They say, okay, didn't used to worry about the savings from a house perspective, but now when it's my house, my office, my school, this starts to make sense. And this idea that if it was about the money, we would have been doing this years ago. But the fact of the matter is, this was a development out in Calgary that was able to show that a net zero house had roughly the same cost of ownership of a standard building code building. So that you get this idea that it's a good investment is where we want to get to. And when you understand the total cost of ownership, it becomes a win-win-win. A win for the utility. You're going to say, why a win for the utility? Because they get to service more houses with the same gas pipe. A win for the homeowner because they get a better house, a better building, a better school, a better office for the same monthly cost. And a win for you because you get to build a high-performance house that's safer, healthier, more comfortable, more durable over time. So very, very powerful. And of course, you're going to recognize they need some proof on that. As I finish up just a few slides, recognizing that it's very important in this conversation with proof statement to develop proof statements. CHB's done a really nice job of this to understand that this is the net zero ready, the net zero program is so powerful because it gives people a seal of approval, a seal of trust. Just as an example of that, the property management fellow who called me from Toronto, he said, is there some sort of certificate that I could get, that I could give to my tenants that would show that I've done everything possible that I can do? Isn't that interesting? In a business sense, the property management firm wants to be able to prove to his clients that they've done everything possible. And I said, frankly, there is nothing. I said, in housing, there is. There's programs like Energy Star, programs like Net Zero Ready that allows us to certify or qualify houses as being higher performance. There's very, well, LEED, I guess you could do that, but these are existing buildings. So LEED certified buildings would help you with this as well. So I did mention LEED. He goes, I don't know if I can do that at this point. But the idea of certification or validation is really powerful. And then just to say the last few slides, I said to you at the beginning, is it okay to talk about this? So Steph, let's do that last poll real quick. Last poll. Yeah, it should be no surprise, right? Of course they want all of the above. They wanted all of that. Oop, how do I get rid of that again? Ah, sorry. My apologies, be right back, just a second. Can't seem to get rid of that poll. Can you still see the poll on my screen? Steph, can you still hear me?
I do not see it on your screen.
Okay, good. So I can just finish up.
Yeah.
So the point was that everybody would say all of the above, right? And so understanding that the expectations are changing, have changed. When home and office are one, when the investment value becomes more important, and there are long-term considerations to the decisions they're now making. I just want to remind you, it's okay to talk about this, to say to people in a soft way, the same things that we've been doing for energy, the same things we did for mold, the same things we did for radon back in the day, also have impact from a COVID perspective. So you're not you're not taking advantage of the situation. You've been there. You've actually done this over time. You haven't changed the way you're building if you're building high performance. It just turns out that high performance houses are indeed better from an overall health and wellness perspective. So keep that in mind. The second thing you do understand is buyers are fairly fickle. It turns out that 80% of air conditioners are sold 2 days after the hottest period in May. That is, people forget about their air conditioner until the hot day in May, and all of a sudden everybody needs air conditioners. We know that 90% of renovations are done in the 6 months before somebody sells a house, and the 8 months after, or 18 months after they buy the house. Our minds are busy, and therefore they're focused on very specific things at points in time. And maybe I said 90% of the 60% of rental stuff. You know that number better than I, but you get the idea. When something comes to the fore, like COVID, we absolutely can help people and give them assurance. Why? Because we're not doing anything we haven't been doing anyway. That's why you have the legitimacy, the credibility to say, we absolutely can help you with this. And yes, we should still need to physically distance, and yes, we need to wash our hands, and we need to be careful, but the houses we're building have this tremendous value. And the summary is this: high performance houses are of tremendous value. They were tremendous value in the times of energy crunches back in the 70s and early 80s. That's why we started doing high performance. They were very important in the radon concerns of the 90s, when radon was all the rage in the United States. They basically started building high performance houses. We see the same here in Canada. They were very big in the mold concern days. That also happened in the 90s, and we went right back to the principles of high performance houses managing moisture. And they've always been there for overall wellness. That is, CMHC, when they developed a housing protocol for the environmentally hypersensitive, Virginia Solaris, CMHC created a protocol to build houses for the environmentally hypersensitive. Frankly, they used R2000 as the basis of construction. The same principles we used for energy, we also used for health, safety, durability, and comfort. Hopefully that's useful to you as we finish up. And so for the pandemic, the good news is the viruses are impacted in the same way, or at least are in the same category, that we can minimize infectivity rates if we build high performance houses. So hopefully that was useful to you. I mentioned at least five value propositions. There's more than those, but we'll just move to questions, Steph.
So actually, I don't see any questions right at the moment. So if anybody has questions, feel free to put those in the Q&A. So far, I think you were quite thorough.
I don't know if I was thorough. I had trouble finding words today. I'm not sure why.
Oh, well, it was the turkey from Thanksgiving.
There you go. Oh, so let me answer the question. I did say I'd answer the question about the standoffs. Yes, indeed. Yeah. That basement wall was showing a standoff. This is used, frankly, in high expansive soils. They actually hold the bottom plate off the wall. They anchor it down with some J-bolts, basically, or a bolt that's drilled into the slab. What's also nice, though, is that means that bottom plate is kept off the slab. So if the basement does flood, it doesn't wet the wood. So it's actually a standoff that was originally pioneered for expansive soils, Denver and places like that, but it's also used in the IAQ world. That's exactly why I showed it, because you'd like that bottom plate not to be sitting on potentially the damp or flooded concrete. So that's what that was about.
Ah, okay, thank you. We did just get one question pop up, and this has got to do with basement insulation. So for basement moisture and air sealing, is there a carbon smart alternative to foam?
Sure. Well, the good news is insulate from the outside. Well, somebody's going to say, well, is there a carbon smart alternative to concrete? And that's coming, of course, aerated concrete and so on. There are systems like Superior Wall and so on that, excuse me, a poured system that include a foundation with foam in them. But there's absolutely no problem using a product like a rock wool or thermofiber on the outside. Historically, Tough and Dry is a brand name, but it was a fiberglass product, or there's a mineral wool product that can be put on the outside, and most would, I believe, agree that that's a lower carbon. It doesn't do you as much good on the inside because it doesn't manage moisture as well, because basements want to drive the inside. So I would use those products on the outside. You're going to say, what about the above grade portion? There are ways of finishing it above grade. Well, you can't fly to Minnesota right now, but Minnesota does all their basement insulation on the outside, and they have various coverings and strategies for covering the above grade portion. But even if you just do the below grade portion, that still warms up the inside of that wall and therefore makes it drier. So if you're looking to avoid foam, then you would put a product like a mineral wool or fiberglass mat board on the outside. Make it thick enough that it's worthwhile, 2.5, 3 inches, and even if it's just a below grade portion would be a choice.
Okay, so those are all the questions that came in. So thank you so much for that. Now I'm going to ask if you could, there you go, stop sharing your screen. And I have one last thing that I'm going to share here. So can you all see that? That's our next event.
There you are.
Yeah, okay.
And can I speak to that for a second?
Sure.
I've had the pleasure, of course, I've known Doug Terry now 15, 20 years. I've had the pleasure of reviewing, he asked me to look over parts of the book that he's written. And you will know, hopefully you will know, if you don't know, Doug's a very passionate advocate of the industry. And here again, he's just done this really cool thing. He's written a book from using his voice that talks about the trials, tribulations, the interesting parts, the things he's learned about net zero. And just to make it more practical for you to get there, I think you're going to really love the book. Parts of it you're going to go, I don't do it that way, and Doug's going to be the first one to say, fair enough. I did it that way, you'll find another way, but really understanding, take I would say the lessons out of it, that it is a bit of a journey. You're going to learn from it, and he can shorten up that journey for you. So if you don't mind, I'm just going to make that plug. What a great opportunity. And Susan, so cool of you guys at Enbridge to recognize the value that this would have to the building community, shorten up that cycle, help builders get to net zero much sooner. So thank you for that.
Thank you, Gord.
Thank you, Gord.
Thank you. So yeah, so our next session, because he's going through the book, which is called A Builder's Guide to Net Zero, he did preface that by saying from bleeding edge to leading edge, because he has been on the bleeding edge of this right from the very beginning. He actually lives in my hometown and built the net zero ready home that I presently live in. So it'll be a fun dialogue. It is a 4-part series because it is going through much of the book. So when you sign up, be sure to sign up for all 4 because each session is different. And so I will send you a link after we're done here. I'll send you a link with the webinar where registration page where you can sign up along with the PDF of Gord's presentation today. And also, when we close the session, a little box should pop up that has a SurveyMonkey link. So if you wouldn't mind filling that survey in, that would be great. And in the meantime, if you miss it, I'll also send you the SurveyMonkey link in email. So thank you again, Enbridge and Susan, for your support. And Gord, thank you so much for bringing your presentation to us. We appreciate it.
Well, I'll say thanks again to Enbridge. And I will say, normally this time of year, I'm certifying for a hockey referee. So go ahead and be brutally honest with me. I'm used to people yelling at me from the ice. I'm kind of missing that right now. So go ahead and give me a tough result. Thank you.
Okay, well, that's all we have, and we ended exactly right on time. So fantastic. So I hope you all have a wonderful afternoon, and we'll look forward to seeing you on November 5th for Doug's session. Thank you. Bye.
Thanks, Susan.
Bye.